Hello everyone and welcome to this channel. My name is Mohib and today I'm going to show you how we can implement transparent data encryption to encrypt an entire database. This is a really important security feature of SQL Server, especially if you are preparing for DP203, which by the way is a Microsoft exam to get certified as a data engineer. Then watch this video till the end and you will surely be able to ace a couple of security related questions in your exam. Speaking of which, there is also a video on dynamic data masking on my channel, which is another really important exam topic related to security. I'll put the link of the video in the description below, so do check that out as well. Alright, so let's start our today's topic. What is transparent data encryption, or TDE in general? Well, it's a process that encrypts files before storing them on the disk, which is also referred to as encryption at rest. When TDE is set to on, it encrypts data and log files of the entire database and hence protects the data stored on the disk. Imagine you have a database without encryption and everything is going well, but one day your physical disk containing a database with highly confidential data gets stolen. I know the chances of this happening are extremely low given the security measures taken at the site of the data center these days. But still, we live in this world and security breaches do happen. Anyways, your disk got stolen and the database files are restored on another server, and now the stealing party has full access to all the sensitive information stored in the database. This is where transparent data encryption comes in. If TDE was implemented, the database would have been encrypted on the disk and protected by keys and certificates. The malicious party would have no way to restore the database without getting access to the keys, and the keys, by the way, you should never back up on the same disk. We will talk about more on backing up keys later. Moving on, let's discuss other features of TDE. TDE does real-time I/O encryption and decryption, which means that the data is encrypted before storing it on the disk, and when a select statement is executed, it is decrypted back and stored into memory. It supports standard encryption algorithms like AES and triple DES, with AES being the more advanced one. Triple DES is actually deprecated since SQL Server 2016, and if you have an older database with triple DES encryption, but you have upgraded to SQL Server 2016, then it's not going to work until you lower your compatibility level in the server settings. So I would say you should upgrade your encryption algorithm to AES if you want to get maximum benefit from upgrading to SQL Server 2016 or later. Finally, TDE encrypts database files on page level. So it encrypts page by page until all of it is encrypted. And the important thing is that encryption does not increase the size of the database. If the database is huge, it does take some time to encrypt the whole thing. So in SQL Server 2019, they gave us a feature where we can pause the encryption process if it is needed, and then it can be resumed anytime later. Now let's have a look at the encryption architecture and how it's managed on the database server. This diagram is taken from Microsoft's documentation, and you can check out their page using the link in the bottom left corner, which I will also put in the description below. So here is the encryption hierarchy, and it starts from the operating system level, which has a data protection API that encrypts the service master key of SQL Server instance. The service master key is automatically created when SQL Server is first set up, so we don't have to worry about it. This service master key is used to encrypt the master key of the master database, and creating a master key in the master database is the first step to implementing transparent data encryption. So we create master key using the create master key statement as shown here, and straight after that, as a second step, we create a certificate that is protected by the master key that we created above. This certificate has a private key that is used to decrypt the data whenever it's read. So it's important to back up the certificate and its private key, because if we lose that, we won't be able to restore an encrypted database to a new server. I know it's a bit confusing, but things will become more clear when we head to the demo and actually implement TDE. So the first two steps are done in the master database. Now we switch to the database we want to encrypt, and here we create the database encryption key, also called DEK. And here we also specify the encryption algorithm that we want to use. This encryption key is protected by the certificate we created in step 2. So as you can see, layers of protection are set in place to ensure security before a database can be encrypted or decrypted. Now, as a final step, we just need to set the encryption to on, which will use the specified algorithm to encrypt the entire database. Now, it is important to understand all of these steps, and as I said earlier, it is frequently asked in the data engineering certification exam. Questions like, what are the steps you need to take in order to implement transparent data encryption? So you need to know these steps in order to answer correctly. And the best way is to practice and implement TDE on some test database. And I'm definitely going to show you in the demo how it all works, so stay tuned for that. Moving on, here I have listed some important DMVs, the dynamic management views that we need to look for in order to check the status of different keys and certificates. Also, when and who created those keys. We can also check the encryption progress, like how much encryption is complete and how much is remaining. Is there any blocker, etc. I will show you all of this in the demo, so let's not waste more time and let's jump to our SQL Server Management Studio to implement Transparent Data Encryption. Alright, so I'm in my SQL Server Management Studio, and here I have an AdventureWorks database that I would like to encrypt using Transparent Data Encryption. And to do that, the first thing I need to do is to create a master key in the master database. Alright, so I'm going to switch to my master database, and then I'm going to say create master key, and then I would encrypt my master key using a password, right? So let's just run this whole thing. And now my master key is created, and we can actually see it in our sys.symmetric_keys DMV. And here you can see that we have our database master key. And we also have our service master key listed here. And as I said earlier, the service master key is automatically created when we first set up our SQL Server instance, right? So the service master key is actually encrypting our database master key, right? So moving on, in the second step, we need to create a certificate. And this certificate is really important because it is used to encrypt our database encryption key that we are going to create later in our AdventureWorks database, right? And it also creates a private key, which is really important as well because it is required to decrypt the data when it's read into memory, right? So the create certificate command is really simple. I just have to specify a name and a subject, and then I'm going to run this, and my certificate is now created. And I can actually also see my certificate in the sys.certificates. And here is our certificate, right? And in this column, it says encrypted by master key. So you can see here that our certificate is encrypted by the master key, right? So we are done with what we have to do in the master database. Now in the third step, we are going to switch to our AdventureWorks database. And this is the database that we are going to encrypt. And now we have to create a database encryption key, right? And with this, I'm also specifying the encryption algorithm. And in this case, I'm using AES 256 algorithm. This is a 256-bit algorithm, and you can also use AES underscore 128, which is a 128-bit algorithm. And with that, we are also specifying our certificate here. because our certificate is going to encrypt this database encryption key. All right, so let's just run this, and my database encryption key is now created. But it's also giving me a warning, and this warning is pretty much self-explanatory, so I'm going to read it out for you. So it says that the certificate used for encrypting the database encryption key has not been backed up. And by certificate, it means this certificate. And you should immediately back up the certificate and the private key associated with the certificate. And if the certificate ever becomes unavailable, or if you must restore or attach the database on another server, you must have backups of both the certificate and the private key, or you will not be able to open the database, right? So basically, certificate is the main thing here. If it ever becomes unavailable, or if you later want to restore your encrypted database to another server, then without the certificates, it won't do it. Right, and I'm going to actually create the backup of the certificate and the private key in a minute, but first I want to just finish with the encryption process. So we created our database encryption key here, and then as a final step, we just need to alter the database and set the encryption to on, which will start encrypting our AdventureWorks database, right? So if I run this, now my database AdventureWorks is being encrypted, and I can actually see the status of my database. Sorry, excuse me. I can actually see the status of my encryption database here, and this 7 is my database ID, and an encryption state is 3, which means that the encryption is already completed. Ooh, that was fast. I didn't expect that. But it makes sense because the AdventureWorks database is not too big, so it didn't take much time to complete the encryption process. Okay, so we have just successfully encrypted our AdventureWorks database, and it's safe and secure in the disk. That is, the database pages are first encrypted and then saved in the disk. All right, so let's do it. Let's create a backup of this encrypted database, and let's try to restore it on another server and see what happens, right? So as I said earlier, that we need to create the backup of the certificates and the private key as well. So here with this script, I'm backing up my certificate on a file path, and I'm also backing up my private key on another file path, right? And I'm encrypting the backups with a more strong, like I said, more strong password. So it needs a strong password here. And you want to remember this password as well, because we are going to need that later. So keep it saved somewhere secure. All right. So let's do it. Let's back up our certificates. Oh, so actually I'm on my AdventureWorks database, and the certificates are created in the master one. So I need to switch to my master database, and now if I run this, it should create the certificate. Yeah. Okay, so my certificates are backed up, and now as a final step, I need to back up my actual database. So it's a standard backup script, and I don't need to explain it. All right, let's do it. And meanwhile, I can, if I can pull up the backup files. So here, as you can see, that my certificates and the private key got backed up on this folder, right? And our database is also backed up. Okay, now let's jump to another server and try to restore our database. Alright, so now I'm on another SQL Server instance, and my goal here is to move my AdventureWorks database onto this server. I've already copied my AdventureWorks backup file from the source server to the exact same location on this server. And here I have a restore script that would restore the database on this server. So let's run this. And as expected, it returned me an error, and it says cannot find server certificate. Right, so as I said earlier, since our AdventureWorks database is encrypted, it cannot be restored on another server without the same certificate and its private key that we created in the source server. Right, so let's create our certificate. So we're going to create our certificate using the backup file of the certificate itself and its private key that we created in the source server. I've already copied over those backup files on this server, but first we need to create the master key, because without the master key we cannot create the certificate. So let's do that. And it created my master key. And now I can create my certificate using the backup files that I copied over on this server from the source server. So here is the script to do that. And if you remember, while creating the certificate backup, we encrypted the files using a strong password. And now here we are decrypting the files using the exact same password. So you need to keep this password safe, otherwise you won't be able to create the certificate. So let's run this, and our certificate is now created. And now we should be able to restore the AdventureWorks database. And without wasting any time, let's run the restore script again. And I think it should restore it. Oh, it's taking some time, but it's okay. All right, it worked. And now let's check in the sys.databases. And as you can see, here is our AdventureWorks database. And let's see if it's encrypted or not. So this has a column called is encrypted. And if I run this, so here it is, our AdventureWorks database is encrypted. So we have restored an encrypted database from the source server, and in the target, it is also encrypted. All right, so this was transparent data encryption for you. We saw how we can encrypt a database with a step-by-step approach of first creating keys and certificates and then encrypting the database itself. And we also saw that after the database is encrypted, it cannot be moved to another server unless we create the same certificate on the target server. And how it's important to always back up the certificate and its private key for this very purpose. And also to prevent any potential data loss if your encrypted database becomes unavailable for any reason. So that's it for this video, and I hope it was useful. Thank you for watching, and I'll see you later. Bye.